Literal equations, 3.6, using formulas and literal equations. It says, a literal equation is an equation that contains multiple variables. We sometimes call this a formula, and you've dealt with formulas in the past, and let me explain something. In geometry next year, you'll deal with a lot of formulas. You'll deal with area formulas, volume formulas, all sorts of formulas. Okay, Pythagorean theorem is another type of formula, but you've got in mathematics you have all different types of formulas. If you learn this, guys, makes using formulas much easier. It says one example of a literal equation or formula, I'll probably use the name formula more often, is this. C equals 5/9 times f minus 32. Somebody look at that formula. Can anybody explain to me what that's the formula for? What does that do? Fahrenheit to Celsius, or Celsius to Fahrenheit. That's how you convert back and forth, either from Fahrenheit to Celsius or Celsius to Fahrenheit. And that's what it asks you to do in these first examples. Use this formula to convert back and forth, and it tells you, it says convert each temperature from degrees Fahrenheit to degrees Celsius. It gives you 50 degrees Fahrenheit. So, are we going to plug that in for the F or the C? The F, and that's going to tell us what the C is. And if you watch real close, these aren't too bad, these first few. So pretty much all you're doing is take out the F and put what? 50. So you have C equals 5/9 times 18. I'm going to show you a shortcut here. You can do it the old way. 18 over 1. We reviewed it the other day. 9 and 18, will those cross cancel? Yes, mark them out. Put a 1 and a 2, because 9 goes into both of them. 9 into 9 is once, 9 into 18 is twice. Multiply the tops, multiply the bottoms, you get 10 over 1, which is 10. So 50 degrees Fahrenheit is equal to 10 degrees Celsius, but that wasn't the shortcut. Let me show you the shortcut now. 5/9 times 18. And a lot of people last, our first block, didn't understand the shortcut, but watch closely. If you understand it, it's going to help you out. AJ, raise your head up, son. Can anybody do 1/9 of 18 for me? A 9th of 18. How would you do 1/9 of 18? Let me explain to you what 1/9 of 18 means. If I have $18 and I'm going to give you 1/9 of it, that means I'm going to give you 1 out of every $9. So if I have 18, if I'm going to give you 1 out of every 9, I'm going to give you $2. Does that make sense? 1/9 of 18 is 2. What's a 9th of 27? 3. What's a 9th of 45? 5. Skip forward in there. What's a 9th of 90? 10. Can y'all do that? Because really you're just dividing by 9, right? I'm going to kind of go off track for a second. What's a 4th of 16? 4. What's a 4th of 32? 8. Do you see what we're doing? We're just really dividing. To find a 4th, a 9th, or whatever, you're really just dividing. Okay, let's go back to this problem now. We want to do 5/9 times 18. What's 1/9 of 18? 2. So what would 5/9 be? 5 of those, right? 5 2s is 10. Same answer. You see that? Huh? Because what I did is I did 1/9. 1/9 of 18 would be 2, but I don't want 1/9. I want 5/9. So you multiply it by 5, and that'll give you. Yeah. But somebody said that first block too. Let me explain to you something. I'm not all about, well, we could divide by 9 and then multiply. The reason I'm not is because if you learn it like that, you're not going to remember how to do it. If you learn why you do what you do, because again, what I did is I took it 1/9 of 18, but if I want to find 5/9, you just do 5 of those. So if you remember why you do what you do, you're 10 times more likely to remember how to do it. Just a couple more before we go on to the next problem. If I ask you to do 5/9 of 45 now, 5/9 times 45 is what? 25. So you can do them in your head now. Because 1/9 would be 5, so therefore 5/9 would be 25. What would be 5/9 of 81? 45. Yes, that's right. 5/9 of 81 is 45. What would be 5/9? I'll give you a tough one. 5/9 of 108. 9 into 1/9 is 12, so 5/9 would be 60. Okay, so now that you know, hopefully some of you know how to do that, then we're pretty good. Second problem, yeah, it's a whole lot easier, but the only thing is you can't always use it. You can use it when you can take a 9th of it real easy. You see, like if you wanted to do 5/9, here's where the shortcut wouldn't work. 5/9 of 40. Do you see that? You can't do a ninth of 40 real easy. Tell you what you could do on your calculator though. You can do a ninth of 40. You can do 40 divided by 9, hit enter, and then do that times 5, and that'd still give you the same answer. But anyway, back to this. Celsius equals 5/9 times F minus 32. There's your formula. And it gives us 212. Before I even do this problem, yeah, thank you very much. That's what I was fixing to say. That should be 100 degrees. We're going to take out the F and put a 212. How did he know that? Boiling temperature of water. Right? 212 degrees Fahrenheit, which should be the same thing as 100 degrees Celsius if we work it right. So C equals 5/9 times, what's this? 180. So let's use our shortcut. Because 212 degrees Fahrenheit is 100 degrees Celsius, that's the boiling point for water. It's kind of like 32 degrees Fahrenheit should be 0. It's science. So, there you go. So here we go. 5/9 times 180. Let's use our shortcut. What's 1/9 of 80? 20, so 5 of them would be, which is what he said, 100 degrees Celsius. So 212 Fahrenheit, 100 Celsius. That's pretty easy, right? The last one, 104. So we have C equals 5/9 times F minus 32. But we want 104 degrees Fahrenheit, so put a 104 in for your F. So we have C equals 5/9 times 72, which should be 40. 1/9 of 72 is 8. 5 of them, therefore, would be 40. Good job. Y'all picked up on that really good. Sometimes the ability to manipulate these equations and solve them for particular variables is valuable to us in mathematics. So what we're doing is we're fixing to start solving more equations. The funny thing about the equations we're fixing to start solving is they don't have numbers. They're formulas. They're just a bunch of letters. One fact that will help us in this task is that of moving terms. And I told you, anytime you move a term across an equal sign, if it's plus 2 over here, it becomes minus 2 over here. If it's a minus 3x over here, if you move it across the equal sign, it becomes a plus 3x, right? We can move a term from one side of the equal sign to the other side simply by changing the sign of the term. We then use previous methods to completely isolate the variable. Let me explain to you what we're doing. A equals P plus I, and it has I underlined. All that I'm wanting to do is get I by itself. Oh, I'm sorry. Thank you. I was seeing if I was looking at your notes. A equals P plus I with P underlined. I want to get P by itself now. When I say by itself, a lot of people still aren't getting this. Look where your equal sign is. Do you see that this is on the same side of the equal sign? With me? So in order to get P by itself, what in that box am I getting rid of? The plus I. Makes sense. Is the plus I, is I a term? Yes. So therefore, if I want to move plus I across that equal sign's magic. Anytime you move a term across that equal sign, it changes its sign. So plus I becomes negative I, or minus I. So now I have A, and I have what else? A minus I equals P. Is P by itself? Yes, that's all we're doing. And if you want to write that, I actually like it better as P equals A minus I. Since you're wanting to get P by itself, go ahead and put it on the left side. It just looks better. And that's it. Understand the first ones? Yes, sir. If we use the first one like this, that's fine. It's the same thing. Yes, sir. No, because what it'll say in your book is it'll say solve. This is your directions in your book. It'll say solve A equals P minus I for P. That's the way your book will give the directions, and what that means is get this by itself. Move the I over. Makes sense. Yes, sir. Okay, that's a good question. Does the order matter? A equals P plus I. What if I wanted to put my I first over here? It's going to be negative I, right? Because you moved it over, positive to negative. What about the A? Did you move it? So it'll be plus A equals P. Would that be okay? Yeah, that's fine. Yeah, because A minus I looks better just because negative a plus I looks like you got a negative and a positive. To where here you got a negative and a positive also, but you're using